Hey guys, this is TechPy, and in this video we are going to code a neural network from scratch in Python. So before we get started, I want to tell you that there are a few things that you should know. For example, you should be aware of what object-oriented programming is in Python, of course. And what I mean by that is you should be aware of what a class is, what a function is, how to create an object. Just the basic things, right? Secondly, you should be aware of how a neural network works. And if you don't worry about it. I've got you covered in this video. So this is a neural network. The blue circles are called as neurons and the red lines are called as connections. The neurons are stacked vertically to form a layer, and then these layers are stacked horizontally to get a neural network. Now, what are these neurons and what are they actually doing? Let's find out. So this is a neuron, and these lines are connections from the previous layer, and these lines are connections to the next layer. Let's keep the connections aside and look at the neuron itself. The neuron is said to have parameters W and B, also known as weights and the biases, and it also has something called as an activation function. So for the sake of simplicity, we're going to consider that this neuron has a single input and a single output. The input is called as X and the output is called as A. It will multiply the input X with the weight W, add the bias B to it and get Z. Now we will apply the activation function to the Z, and that's how we get the output A. This was the case for a single input. What if we have multiple inputs? Multiple inputs are fed to the neuron through multiple connections, and these connections have their own weights. So the same way, we're going to multiply the input x1 with w1, x2 with w2, x3 with w3, add the bias b to it, and that's how we get the updated equation. Now this looks a bit messy, so we are going to represent w and x with their vector representations, and that's how we end up with this. The activation function is going to remain the same, so no changes on that part. The same concept can be scaled to all the neurons inside this neural network, and that is forward propagation for a neural network. So let us start with our coding. I will first define a class and name it as neural network. I will define a constructor for this class, and for the time being, we don't know what values we will be putting inside that, so I will be just putting pass here. So I'm going to define a method and call it add, which is going to take the number of neurons for every layer and construct the neural network. So one of the parameters obviously would be layer size, which will point to the number of neurons inside that layer, and also every layer will have its own activation function, so we're going to pass that as an argument. Okay, so first of all we need to track how many layers are there inside the neural network. So inside the constructor I will define an empty list called layers, which will keep track of how many layers are there and how many neurons are there inside it. As soon as we call this function, so we'll be going to append the values of the number of neurons inside this self.layer list, inside this layer list. So how do we do that? We access the layer list and then we append layer size to it. But we also need to keep track of the activation function inside the layer as well for every layer, because they could be different for every layer. And for the sake of simplicity, we're going to just assume that the default value of any activation layer is equal to relu. So what I think we should do is we should be appending a dictionary every time we get a new layer inside the neural network. So how can we do that? This is the syntax for defining a dictionary, and inside that we are going to pass the neurons parameter, and the value of that would be equal to layer size, and then the next element in this dictionary would be the activation function. So I will just write this as activation, and the value of this would be equal to the parameter activation function itself. So before we actually start with the forward propagation, we need to initialize the parameters. Note that the parameters W has dimensions equal to number of neurons in the current layer times the number of neurons in the previous layer, and the dimensions of B in the same layer is equal to the number of neurons in the current layer times 1. So for the first hidden layer, the dimensions of W will be equal to the number of neurons in the first layer times the number of input features. So I think we should find a method known as initialize parameters, and I don't think we need any arguments for this, and actually we will be only calling this function one time. So we need to find out what is the value of L, which is equal to the number of layers inside this neural network, which will be equal to length of self.layer, I believe, yes. And now for I in range 1 to L, we can simply do wtemp is equal to np dot, okay, so we haven't yet imported numpy, so we'll just go ahead and do that. Import numpy as np, and then we can write wtemp would be equal to np.random.randn, and that would be equal to the number of neurons in the current layer. So we can do that by accessing ith index of list named as layer. So we can do that by writing self.layer at the ith index, and we need to provide a key for this dictionary, because if we get to this ith index, we are going to point to this dictionary, and for this dictionary this key neurons points to the layer size, which is equal to the number of neurons in that layer. So we can write here neurons and times self times number of neurons in the previous layer. So we can write self dot layer of I minus 1, and the key would be the same, so I will write neurons. This is for W, and for B we can write np.random.randn, same thing, but now the dimensions are equal to the number of neurons in the current layer times 1. So we can just write self.layer I times 1. So that is going to define W and B for us, but we also need to store it. So for that we are going to make another list called as parameters inside the constructor, not here, inside the constructor, and we can call that self.parameters, and this is going to point to an empty list initially. So we need to append these parameters to our list parameters, and we can do that by writing self.append and then the parameters. We'll again store these parameters inside a dictionary and write them as the key would be W and the value will be equal to wtemp, and same thing for B, the key would be B and the value would be btemp. So this is going to initialize the parameters for our neural network. Now we actually need to do forward propagation. So a single step inside of our propagation, we can write a function and call it forward step, which would be equal to, now a forward step inside a neural network involves the calculation of Z, which is done by multiplying the weights W with the previous activation layer and adding the bias B to it, and then applying the activation function to get A. So we'll need the weights, the activations from the previous layer, the bias B, and the activation function itself. We can calculate Z, which would be equal to np dot, which should be equal to dot product of w and a previous activations from the previous layer and adding the bias b to it. And now the activation of this layer would be equal to activation. We'll define a function called as activation, so dot activation, and we'll provide the value of ztemp to it along with the value of activation function. So now we need to define this function called as activation, and the parameters that it requires are z and the activation function. For example, a ReLU is a simple activation function. If the input is greater than 0, the value is equal to whatever the input was, and if the input is less than 0, the output of this activation function is equal to 0. So we can put an if condition here. If the activation function is going to be a string which is going to store the value of the activation function. For example, it could be ReLU or it could be sigmoid. So a would be equal to np dot maximum of 0 and z, but this needs also to be inside an numpy array, so we can write np dot array and then this value, and then we are going to return a. So now that we got z temp and a temp, I'll just put this as capital Z and this also. So there are a couple of mistakes that I made. First of all, the name of this function should be activation and not activation function. And then what is the self.append? I'm appending to the parameters list, so I'll just call it parameters. And then the same typo happened somewhere over here, right? So we're just going to change that as well. Now we just need to define a function which is going to calculate the forward propagation for all the layers inside the neural network. So we're going to define a function called as forward prop, and I don't believe that we need any parameters for this. We're just going to take the number of layers is equal to self dot is equal to length of self dot layers, and the same word for loop for I in range of L1 to L, sorry, we can calculate the forward propagation to be okay. So we need to return these values ztemp to be able to access them inside a forward prop. So we just go return these values, and here we need to pass w, we need to pass b, we need to pass the activation function as well. So w we can get by accessing self dot parameters ith index, and the value of w would be accessing the key, dictionary key w, and the same way for b, but this time instead of w we are going to replace it with b. So just write b here, and the activation function, this comes from the layer list, so we're gonna write self.layer the ith index, and the key would be, what is the key again? Activation. So we're just going to copy this and paste that here. Now that we have this out of the way, we can get the every value of c. We can get c and a, which should be equal to forward step, but this is an inside function, so we'll write self dot forward step, and this would be equal to, we'll just pass the parameters w, and okay, so there's a typo here, fix that, w b, and then the value of a previous. So for the first thing, there's this a previous coming from. For the first trigger, the a previous is equal to inputs. And then we'll just simply write a previous is equal to inputs. And then the normal flow will go on. Yes, then we can pass self forward prop w comma a previous comma b, and the activation function to it. Activation function. So we need to store this value of z and a, and I'm going to make another dictionary this time, and that would be equal to self.forward cache. This is an empty dictionary for now, and we can write self.forward cache of key would be z, and string value of the iteration, and the value would be equal to z, and same thing for activation a. Now, so at the end of the iteration, I can simply say that the value of a previous would be equal to a. So with this, we have completed our forward propagation for this neural network, and in the next video I'll be showing you how to do backward propagation. Until then, stay safe.